Hi, this is Calculus 12, Chapter 3.5. We're going to be looking at derivatives of trigonometric functions. This part is reviewing trig functions. If you need to review it, please watch the extra video. If you haven't done trig functions, please watch the extra video. So if you're going to prove the derivatives of the trig functions, you need to know trig identities. Otherwise, you won't be able to solve the derivatives with limits. And just a reminder, here are your basic trig identities. We need the sum and difference identities. And if you don't know them, you can look it up in your textbook on page 580. Recall that we had these properties. Limit as h approaches 0, cos h minus 1 over h equals 0. Limit as h approaches 0 of sine h over h equals 1. And we still can't prove these yet. So find the derivative of f of x equals cos x. So we start out with the substitution. So we'll do cos x plus h minus cos x all over h. Limit h goes to 0. And we want to use the cos sum identity. So we have cos x cos h minus sine x sine h minus cos x. And the cos x is coming from there. So that part's the identity all over h. So we want to rearrange this. We want to combine these two so we can factor out the cos x. Limit h goes to 0. So we factor out a cos x. We get cos h minus 1. Remember, when we factor out a cos x, we're dividing by cos x. And we have minus sine x sine h. And it's still all over h. Now we want to break these up into separate limits. Limit h goes to 0, cos x, limit h goes to 0, cos h minus 1 over h, minus limit h goes to 0, sine x sine h over h. So this, we use this and we get 0. So it's 0 times cos x. Here we're using this, we're splitting it up. That gives us 1 minus 1 times sine x. And we get negative sine x. So that's the derivative of cosine. You can try to prove the other trig derivatives. And this is a shortcut for saying f of x equals sine x. The derivative of f of x equals cos x. So the Leibniz notation is preferred here. So the derivative of sine x equals cos x. The derivative of tan x is secant squared x. Derivative of cotangent x equals negative cosecant squared x. The derivative of secant x is secant x tan x. And the derivative of cosecant x is negative cosecant x cotangent x. So when we're asked to do this, we just substitute in the derivative. You want to notice this. d dx sine x equals cos x. d dx cos x equals negative sine x. d dx negative sine x equals negative cos x. d dx negative cos x equals sine x. So every time we take the derivative 4 times, we get back to where we started from. So if we started at cos x and we take the derivative 4 times, we get back to cos x, and so on. Let's look at an example. Find the velocity and acceleration of f of x equals sine x times sine x. V of x equals, this is a product. You can use the power rule if you wanted to do sine squared x, but you don't have enough rules to be able to do this yet. We're going to do this with the product rule. So it's u v prime plus u prime v. This is not the same v as this, okay? So this is u and this is v. One thing about calculus is you're going to have to get used to seeing the same literal in different spots, and you'll have to know that they mean different things. Okay, so if we're using the product rule, we have sine x times d dx sine x plus d dx sine x times sine x. Okay, we can't use Lagrange's notation for this, so let's put that down. Can't do sine x prime. It looks like sine x to the power of 1. So this notation is to be avoided. Okay, and we just figured out the derivative of sine x, that's cos x. Okay, and for multiplication, it's commutative. We can change the order, so this is just sine x cos x. So we have 2 sine x cos x. And if you remember your trig identities, this works out to be sine 2x. Okay, let's find the acceleration. But we'll go back to this answer. So we have 2, and then we're going to use the product rule again. So this is going to be u, and this is going to be v. So we have sine x d dx cos x. Then we have plus d dx sine x times cos x. So this is sine x, and this is negative sine x. This is going to be cos x, and we have cos x. One thing about trig functions, we should always list them in the proper order. So it's normally sine, cosine, tangent. The highest order goes first. So this is order 2 because there's 2 terms in here. Okay, here we're going to put cosine first because it's positive and this is negative. So 2 cos squared x minus sine squared x. Okay, last problem. Find an equation of the normal to the graph of y equals tan x over x at x equals pi over 4. So this is a quotient, so we have uv and y prime equals u prime v minus uv prime over v squared. So we'll just go into u prime, that's secant squared. And v is going to be x minus u, which is just tan x. And the derivative of v is just 1. And we have v squared, so that's x squared. And we just need to clean this up. Polynomial terms go in front of trig terms. So we have x secant squared x minus tan x over x squared. The reason why we don't want to put polynomials after trig functions is because it looks like we're multiplying the two factors together as our parameter to the trig function, which is not our intent. Okay, now we have the derivative. We should calculate the point. So y of pi over 4 equals tan pi over 4 over pi over 4. This is just 1, and we multiply by the reciprocal, so it's 4 over pi. And that's just 4 over pi. Okay, now we need to calculate the derivative. Y prime of pi over 4 equals pi over 4. Secant is 1 over cosine. Cosine of pi over 4 is 1 over root 2. So we have root 2 squared, because secant's the reciprocal. Tan pi over 4, we already calculated that, that's 1. And then we have pi over 4 squared. So this is going to become 2. So 2 pi over 4 is pi over 2 minus 1. So that's 2 over 2. Since this is a fraction, we're going to reciprocate and then multiply. So this is 4 over pi squared. So this is pi minus 2. This squared is 16, and when divided by 2, that's 8 over pi squared. Okay, we want to avoid having fractions in fractions, and that's as simplified as it's going to get. So now we need the normal slope. That's negative 1 over m. So that's negative 1 over pi minus 2, 8 over pi squared. So we can simplify that, minus pi squared over 8 pi minus 2. We can eliminate this negative sign by flipping this binomial. Pi squared over 8 times 2 minus pi. So the normal line is y minus 4 over pi equals our slope, pi squared over 8, 2 minus pi, and x minus pi over 4. Please don't simplify this. This is slope point form, and it's perfectly valid. If you do any extra algebra, you're liable to make a mistake and lose marks for that. And that completes this lesson.